Now there's three different cases that we could have when we're comparing some rational numbers. So a polynomial in the numerator, polynomial in the denominator. And our first one is where the numerator degree is less than the denominator degree. So we're looking at a case where we might have a quadratic in the denominator and the numerator just has degree 1, or a linear graph. So the question here is list all asymptotes of the following functions. And there's going to be a vertical asymptote at the non-permissible value, or MPVs. There also will be a horizontal asymptote at y equals 0 all the time. So basically all this question is asking us to do then is find our MPVs, and that's where asymptotes will be. So it's going to be at x squared minus 9 equals 0. This is a difference of squares, so you get x minus 3, x plus 3. So therefore we get x is that 3 and negative 3, so plus or minus. So I'm just going to use a little shorthand here. Our vertical asymptote is at x equals 3. Oh, we'll go plus or minus x equals 3. Yeah, that's not too bad. Second one's the same thing. Just got to find the MPVs. So x squared plus 1 equals 0. Subtract 1 off of each side. And we're not able to square root a negative, so there's no vertical asymptotes. Now, we did forget on both of these questions so far, actually, the other asymptote, which is the horizontal one. And there is one at y equals 0 then, and same for this one as well. But in this case, there is no vertical asymptote, which means that this graph, if it was not reciprocated, it would have never crossed our x-axis, if you want to go back to the last section. Now, I did say to verify with technology. I'll let you do that. We got one more case left. So x squared minus 16 equals 0. Do this one a little different. I'll add 16 to both sides. Square root both sides, you get plus or minus 4. So therefore, we have vertical asymptotes, and you shouldn't use the shorthand. I'm just doing it in the videos, at plus or minus 4. And that's going to be at x equals plus or minus 4. All right, our second case. The numerator degree is equal to the denominator degree. So you're going to get a horizontal asymptote at y equals the leading coefficient divided by the other leading coefficient. And you're going to have vertical asymptotes at the MPVs still. So that part stays the same. And our question is the same. List all asymptotes of the following functions. Verify with technology. Again, you can do that part. This first part, though, might be a little concerning. Why am I just allowed to say, hey, I can just divide, like in this case, this is the leading coefficient, so 4 divided by 1. So then my horizontal asymptote is at y equals 4. Like, how is that possible that it's that easy? We have to go back to those questions where we were rearranging them and want to look at that transformation. So I have to ask myself if I wanted to make it so I have that plus 4 on the outside, so I can actually see what's being shifted up or down. We're going to want to cancel an x minus 2 out. So if we think, okay, 4x minus, I gotta make it minus 2, so we're gonna go 4 times 2 is 8. And again, that's how I get that factor. Now that means I can add an 8 as well, or not can, have to. So then I'm gonna factor, it's gonna become x minus 2, and then x minus 2, and we have this plus 8 over here. That is still over x minus 2, and voila, you have your 4. So all of that work, that is going to be, and if you don't believe me, I'll write this out in one last step, 8 over x minus 2 plus 4. So that becomes my vertical translation there, and that's just based off trying to cancel the denominators out, and what leads us to this. So there we go. Proven, it's 4. And here our vertical asymptote's really easy. It's just 2. So vertical asymptote at x equals 2. Okay, let's look at our next one. So here, the degrees are the same, both 2. So it's going to be, for our horizontal asymptote, it's going to be 1 divided by 1, which is 1. So then it's at y equals 1. For our vertical asymptote, we're going to look at the denominator. So x squared minus 1 equals 0. We'll go add 1 to each side, and so you square root, you get plus or minus 1. So therefore, they're at x equals plus or minus 1. That's it. Our final one, 3 over 1. Put hey that we're actually talking about the horizontal asymptote here. So we get 3. So therefore, it's at y equals 3. Now I would recommend writing a little bit more. Like this shouldn't say HA, but on the computer it's a little bit tough. So make sure on your paper you're being very, very clear with what you're doing. And then for our vertical asymptote, it's going to be x squared plus 9 equals 0. Subtract 9 off both sides, and oh, I cannot square root a negative, so I have no vertical asymptote. All right, our final case, it's when the numerator is greater than the denominator degree. So there are no horizontal asymptotes then. So make that clear, none. There is a vertical asymptote at the MPV still. Hey, that's good. But now we have oblique or slant asymptotes. And we find that by performing long division or synthetic division to divide the rational expression. We use oblique asymptotes as a drawing guideline to describe the end behaviors of our graphs. This means, like the horizontal asymptotes, a graph can cross it. And that is important, so don't get confused when you see something cross through it. So our example, again, list all asymptotes, verify with technology. Let's do the easy one first, vertical asymptote. Well, that's our NPV. It's at x equals 3. Done. The not so easy one, the horizontal asymptote. Or I guess, well, that one there's none. That one's easy too. But it's our oblique or slanted. So I'll go OA for my... That one's a bit trickier. It says we can use long division or we can do synthetic division. I feel like we do synthetic division lots. So let's go back and do some long division. So x squared minus 4x plus 3. And we're going to divide that by x minus 3. So we have to ask ourselves, something times x gets me x squared. Well, x. So x times x is x squared. And then x times negative 3 is negative 3x. Then we're going to subtract those. So we get negative 4 minus negative 3. Well, that's really like adding. So you get negative x. Drop down the 3. And then x times what gets me negative x? Well, x times negative 1. So then you end up with negative x plus 3. And when we subtract this, we have no remainder. So that makes it nice and easy. And now we have what our slant or oblique asymptote is, which is this x minus 1. So we can say it's at x minus 1. And y equals x minus 1. And if you actually graph this, you graph this right here, and then you were to graph this on top of it, you would see it just fits perfectly between the graphs, unless there's a place where it crosses.